Hello, statisticians. Mr. Youngsaver here from Skew the Script. Last time we looked at a data set from the online dating site OkCupid. We found some pretty good evidence that people were lying in their dating profiles. This time we're going to return to that data set. We're going to ask, how can we use the site such that we only get potential matches that are being honest? In order to do that, we're going to need to learn some new rules for probability. Let's skew it. Today's lesson is on the multiplication rule and conditional probability. This is lesson 5.3 in our course sequence. Last time, we found that some people are probably lying about their height and income on their online dating profiles. This time, we're going to ask, how can we find, if we're using the site, just the honest profiles? How can we find honest potential return matches? If you'd like to follow along using guided notes, you can print them out from this URL on our website. So today we're going to talk about first, conditional probability. And let's talk about this data set one more time. These were data from online dating profiles that are made public, that were publicly listed in 2012 on the site OkCupid. We filter for the people who were age 36, male and heterosexual, living in the San Francisco area. And we collected data for each profile that reported their height and yearly earnings. The full data set is linked down below. Now, why are we looking at just the age 36 profiles? Well, it's a lower bound for the age when men typically earn their median salary. It's kind of like the low side of that, but that's like a typical age. And it's an age when men who are dating online might really start feeling the pressure to find someone. So this data is compared to a couple of medians. We estimated a 2012 median yearly earning for individual men in San Francisco County is about $59,397. This is an upper bound estimate. And then the male median height in the United States is 69.2 inches or 5'9". And we categorize the men as follows. The profiles either fell into a short low earner, so they're below median height, below median income, short high earner, lower than median height, above median income, etc. in those categories. Now, let's talk about conditional probability. A condition is a given. When you see condition, think given in a problem. The way we notate it in probability is with this vertical line. So PA vertical line B means the probability of A occurring given, so the vertical line is given that B has already occurred or you know for sure will occur. So in the OkCupid data set, we find there were 21 short low earners, 22 tall low earners, 48 short high earners, and 101 tall high earners for a total of 192. Let's make event T the event of randomly selecting from that pool a tall man. Event H, the event randomly selecting a high income earner. We can put it in the Venn diagram like this. So let's find the probability of selecting a tall man from the data set. So we find the whole circle and we get all the tall people, for the people who are tall but not high income or people who are both, add them up, divide by the total sample size, 192, we get 64.1%. Now, we always divide, when we're getting these general probabilities, usually by the total number of possibilities. And in this case, total number of possibilities is 192. We're selecting from all the men in a data set, that's the total number of possibilities. Now let's look at a different situation. Let's find the probability of selecting someone who is tall, given they were a high income earner. So in this case, let's look at the given first. We know they have to be a high income earner. So we're going to ignore everything in the diagram except for the circle that represents the high income earners because no one else is a possibility anymore. And so our new denominator, our new number of total possibilities is just 149, just the people who are high income earners. So that's what the given does. It slices the data to make it just out of that total. And now we look for the people who were tall given their high income earners. So that's the 101 who are both. And that is our numerator. So this probability is 67.8% if you do that division. Now, this brings us to the formula for conditional probability. The probability of tall given high income is the probability of both divided by the given. And that was, in our case, 101 divided by 149. Now, I don't want you, as I said in previous lessons, using these formulas too much. Let's talk about an intuitive rule for conditional probability. So probability of T given H was simply the given in the denominator and the people who are still in the event of being tall in the numerator. So essentially, given means do the same thing, but divide by the given. Whatever is given, cut the data set to whatever it is, and then divide by that new total. So the general rule, the intuitive rule to remember is given means divide by the given. In this case, we're dividing by the high income earners. And here's the formula, and here's the intuition. So again, please use the intuition. The formulas can get confusing. Given means take both, divide by the given, divide by the given. So let's use this in a two-way table. So the probability of finding someone who's tall, we can get the total of the tall folks, that's 123, out of the grand total of the table, that's 192. That's 64.1%. Now let's put a condition in there. Let's find the probability they're tall given they were not a high earner, given they were a low earner. So if I know for sure they're a low earner, I can ignore all that part of the table. I'm just going to look at those who were low earners. So the new total, the new total number of possibilities is that column total of 43. Remember, given means divide by the given. So I'm going to divide by 43, my new total number of possibilities. Now I'm looking for the people among those who were tall. So I'm going to divide those 22 who were tall out of the 43. Probability is 51.2%. And let me point out again, we have two-way probability tables in addition to the raw counts tables. The idea is still the exact same thing. So in the probability tables, they already divided for you by 192. And if we already were given the percentages instead of the raw counts, we again ignore everyone who is not who is a high income earner, and we divide the tall probability by the given. And when we do that, we get the exact same percentage. So even those decimals, don't get freaked out. Again, divide by the given and use the event intersection as the numerator. So again, given means divide by the given. That will get you anywhere in givens. Independence. So let's talk about this rule of independence. Two events, A and B, are independent if knowing the outcome of one event does not affect the outcome, the probability the other event will occur. So the probability of A given B, in other words, is the same thing as the probability of A. Knowing that B occurred or didn't doesn't affect at all the probability of A occurring. So the probability that they're tall, without knowing about their earnings, without a given, was 64.1%. However, when we were given that they were a low-income earner, the probability of them being tall lowered to 51.2%. So when we knew the person was a low earner, the probability of selecting a tall person actually shrunk. So the events of selecting a low earner and someone who is tall are not independent. In other words, their earnings gave us information about their height. When we knew they were a low earner, the probability of selecting a tall person was different. That information affected our probability. So earnings and height are not independent. And this is actually found in general studies as well. Numerous studies have found that taller people tend to earn more money. In other words, these variables are not independent. Now, no, correlation is not equal causation. It's not necessarily saying that height causes people to earn more, but there is a correlation there, and these variables are not independent. Knowing someone's height can give you some information and affect the probability of them earning a certain amount of income. So does the income-height correlation in this case on the OkCupid profiles explain this dependence? Well, not necessarily. We're going to discuss this more in our discussion. Now, a lot of people get confused between independent and mutually exclusive. Let's talk about that. We talked last time, mutually exclusive events are when events have no intersection. They cannot both occur. They cannot co-occur. So in this case, let's say there's events A and B. They're mutually exclusive. The probability of event A happening is 0.8. The probability of event B happening is 0.2. There's no intersection in this Venn diagram because they are mutually exclusive. So the probability of A happening is 0.8. The probability of A happen given that B has already happened, well, let's look at that. So we're given that B has happened, so we're ignoring everything except for B. And now there's no probability of A left. It's zero because remember, these are mutually exclusive. They cannot both occur. So if you know that B has occurred, A is definitely not going to occur. So not only are these events not independent, they're extremely dependent. Knowing that B occurred completely affected and erased the probability of A. So knowing that B occurs gives you a lot of information about A. It lowers it to zero. So these are mutually exclusive events are not independent. Now let's talk about the multiplication rule. This is the form of multiplication rule. The probability of A and B happening is the probability of A times the probability of B given A. That's kind of complicated. For independent events, what we just talked about, it's a little bit simpler. The probability of A and B happening is the probability of A times the probability of B. But again, we don't want to be using formulas. Let's talk about some intuition here. Here's the intuitive rule I want you to use. And, when you hear and, that means multiply. And then always account for dependent events. So let's talk about that by using a new type of probability diagram called a tree diagram. Tree diagrams model multiple dependent or successive events. And each branch of the tree represents a different event. So let's look at an example here. We're going to do a tree diagram of getting into your dream school. So say you have a 65% probability of getting a higher than average GPA and ACT score. If you have a higher than average GPA and ACT score, you have a 83% chance of getting admitted. It's pretty good to your dream school, dream college. If you have a below average GPA and ACT score, you only have a 39% chance of being admitted. So it's obviously advantageous to get a higher than average GPA and ACT score. So event one is, let's see, in high school, what GPA or ACT score you would get. There are two options here. You get above average or below average. And we can fill in the probabilities. Probability of having above average GPA and ACT was 65%. So probability of having below average is the rest of that probability, or 35%. You just do 1 minus that. That's how you fill in all the branches. The next event is being admitted to college. And this depends on how well you did on your ACT and GPA. So in the world in which you had a higher than average ACT and GPA, let's follow that branch. You can be admitted to the school or not admitted to the school. And we know from the problem set up that there's an 83% chance that you were admitted to school if you had a higher than average GPA and ACT. So that means the rest of the probability, there's only a 17% chance of not being admitted. In the alternative universe where you had a below average ACT and GPA, you had a 39% chance of being admitted and actually have more than half chance of being not admitted, 61%, because that's what adds to 1 there. So zoom in on this tree and talk about probabilities here. Let's let event H be the event of getting a higher than average ACT and GPA. Let's let event A be the event of being admitted to your dream school. So let's find the probability of H and A, the probability of getting a higher than average GPA ACT and being admitted to your dream school. So in this case, we have to follow the top branch. We have a higher than average ACT GPA, so we need to find that probability. And then the top branch again, the probability of being admitted to the dream school. So remember our intuitive probability rule, and means multiply. So we're going to take those two probabilities and we're going to multiply them. When we multiply them, we get an overall probability of 0.54. So there's a 54% chance of both these events happening. Now let's find the probability of A, the probability of being admitted to your dream school, which is one of the final events here. So this is a little bit trickier. Now, there's multiple paths to being admitted to the school. There's path one where you got a higher than average GPA and ACT and you're admitted. We found the probability of that path already. There's also the path of getting below average ACT GPA, but still making it into the school anyway. And to find the probability of that path, below average and admitted, remember and means multiply, we multiply along the path. So these two paths have two different probabilities, but they're both included in the event of being admitted to the school. So it's either or. You could go down path one or path two. And remember, or means add. That's what we're going to learn last lesson. So we simply just add those paths together, and the overall probability of being admitted to your dream school was 68%. Now let's find the probability of a condition. The probability of having attained a higher than average ACT GPA given you were admitted to your dream school. We found, looking at the given first, that the probability of being admitted to the school was 68%. We just found that out in our last problem. So that is the given. The probability of the given happening, being admitted to the school, was 68%. And remember, given means divide by the given. So I'm going to divide by 68%. I'm scaling the probability by the chance of the given. And now, among these paths, I need to find the path of the event I'm looking for, that I had a higher than average ACT GPA. Well, among these paths, that's the top path right there. We got to get the whole path, the path of both of them happening. So that's 0.54 over 0.68. That gets you a probability of 79%. So to summarize what we talked about so far, here are my 5 intuitive probability rules to get a 5 on the AP Stats exam. Number 1, if no diagram or drawing is given, draw one for yourself. That could be a Venn diagram, it could be a two-way table, it could be a tree diagram, whatever the situation calls for, draw one, and that will help your thinking going into trying to solve the problem. 2, the complement rule. Probability of A not happening is 1 minus the probability of A happening. 3, or means add, beware of double counts. 4, given means divide by what's given, it's out of what's given. And then 5, and means multiply, adjust for dependence. Use these rules and your intuition. Do not depend on formulas for probability. If you depend on these sorts of formulas, often you won't even know where to start and get confused very easily. You will have, in the worlds of DJ Khaled, played yourself. So let's get into our discussion for today. If you randomly sample among the OkCupid profiles of age 36 heterosexual men, we found that 64% chance of getting an above median height person and a 77.6% chance of getting above median height income. And these probabilities will only be 50% of the population. So we raise our eyebrows a bit. There's reason to doubt that these are actually accurate. Maybe some people are lying. But what if we just look at the people who reported they make below median earnings? It seemed like median earnings were the ones that were most inflated. Let's look at the people who actually reported that they earn below median earnings, the people that did that. So if we just look at everyone, the probability of finding someone who was tall was 64.1%. That's without knowing about their earnings. And again, if we filter for the people who just reported low earnings, so given they had low earnings, their probability of being tall was 51.2%. So here's the conditional distribution just for low earners. And we're close to that 50-50 split there. So maybe low earner in this case is acting as an indicator for someone who's honest. So let me ask you that. Do you believe that filtering results for just the men, so given the men just reported below median earnings, would return more honest matches on this online dating site? Explain your reasoning. Thanks so much. Have a good one.